Hello, is it audible?
Level.
Yeah, no, I'm saying am I audible or not? Just let me know first. Alright, so look, Adit, which topic you have to cover? Hello, Adit. Alright, Adit, so look, I'll be starting with the vectors. Okay. The very first topic, vectors. What are vectors? Unlike scalar quantities, a vector contains two components. One is magnitude plus basically the another we have to multiply basically. So another vector is direction. Clear? A vector is nothing but a magnitude into direction. Alright? This is one thing. How we can show the direction? If I just tell you a vector direction, some ways are there. One is I'll just simply call you a person moved 5 meter in north, north basically, east basically, whatever four directions you have. Simply say that this. After you do this, you can see you have included a magnitude, basically the exact value how much the person has moved. The rest part is of the direction. Okay. In the direction it says the like north, east, south, and west and all. Okay. Is this clear, Adrit, till here?
Yeah.
So, hello, Adrit, am I audible? At least you can type if you are not able to speak like in the chat session. Okay, I'm not getting any response from your end. Hello, Adrit.
Sir, can you hear me now?
Your voice is very low, Adrit. You can okay. Do one thing. You can just type. You can just type in the chat box. You can type in the chat box. Okay. Alright. I'll just move to the next. That is vector representation. My Yeah, we'll move next. Okay, so look, in the next case, what we can do is we will go with the two type of vector discussion. Okay, so we have two kind of vector discussion: polar vectors and axial vectors. What is a polar vector? Polar vector is basically where the starting point is given. Okay, those vectors which have starting the vectors have started. Another vector is axial. What is the axial? The ones who don't have a starting point, but these vectors are basically the vectors whose directions vectors basically the magnitude plus direction. Two type of vectors: polar vector and axial vector. Axis vector, not axis actually axial vectors. Vectors have direction which has starting point. Vectors whose direction is along axis of rotation. Whose direction is along axis of rotation. Okay. What does this mean? That if I say this as a vector, this is if I call this line as a vector, this is going to be polar vector because you are given initial point and this is a final point something. If I say about the axial vector, so let's say this is a rotational point. Okay, yeah, this is n axis and there's a bob which is rotating about this axis like this. Okay, so if you just calculate angular velocity something, I don't know whether you have studied this or not, leave it. Just assume if it is rotating about this, so there's something called a parameter omega, which yeah, so it goes towards the top direction. So here the direction of a vector comes here the direction of a vector comes into the along with the like it may be downside, it may be upside, basically along with the direction of the axis of rotation. So this comes as a axial vector. Is that clear? Let's move to the next. That is representation of vector. Okay? Important part. Representation of a vector. A vector can be represented as a vector is equals to a magnitude plus a unit vector. This is a magnitude, actual length or something you can say. If like length you can call in the if it is a distance and all. If it is not a distance, basically actual length or actual width. This is basically a unit vector. A unit vector represents direction. So let's discuss more about the unit vector directly. A unit vector, by the name, magnitude is unity. Magnitude is unity. Okay. What does this mean? Mean to say one. Direction again the same. Whatever the direction this magnitude vector represents, that is the direction of this vector. So basically, this the work of this vector is to represent a direction. Okay, it doesn't provide any magnitude. It doesn't have any contribution in the magnitude. It just gives a direction. Okay. About the unit, this is a unitless quantity because its sole purpose is to represent a direction. Okay. Assume this is my coordinate axis like this. Third is this. This is the, let's say, coordinate axis. Increase this. Okay, let's say this is a vector. Clear? So this is basically coordinate axis. So you will say this is y, this is x, and this is z. So you can see each of them as representing some direction. Okay. So basically, we represent this as x with a I cap, j with a y with a j cap, and this z with a k cap. Okay. If you see carefully, our relation, this also contains a cap at the top. This also contains a cap at the top. So you can simply say that I, j, and k represents direction of x, y, and z respectively. Okay, and are unit vectors. Clear? Now one more thing. If I ask you what is the magnitude again, as these I cap, j cap, k cap are unit vectors, therefore have one magnitude. I hope it makes sense to you. Okay. Now let's cover through some more discussion of the vectors now. We have some type of vectors. I'll simply explain here actually. One is if you have one vector this way, one vector this way, it can be this. Might be this. It can be this way. It can be this way. But they should be at least parallel to each other. Not parallel actually. Like this, you can call this these kind of vectors as a collinear. Okay? A vector, B vector, A vector, B vector. So collinear nature. Collinear means to say they are point. They are in the same line. They are in the same line like this and this. Okay. They might point the one in this direction, one in this direction, but they should be on the same line. That is what the collinear is. What is a parallel vector? If you have a vectors like this, that's another is anti-parallel. What is that? One is this way, another is pointing to the opposite direction. They look, all of them can lie on the same point also, like this, like this. Okay? Now the third is negative vector. Negative is like this is a vector and this is a vector. Another have a same magnitude and but opposite direction. Then you can call this as a vector. This as a negative a vector. Okay. This is vector A. This is vector B. Basically, the direction of vector B is opposite to the direction of A. Here, this is A vector, B vector. A vector is parallel to B vector. Here, this A, B are collinear with each other. Just type yes if we are clear with the things we have discussed so far. So let's move ahead. Equal negative vector coplanar. There is something called coplanar vector. Basically, if all the vectors lies in the same plane, then they are coplanar. So that's what coplanar is. I won't discuss much more. Let's come to calculation of the magnitude of vector. What is the magnitude of vectors? It's very simple thing. Assume you are given a vector A is written as 3i plus 4j. So what is okay? Before this, I'll just explain a single. If I ask you, what is the magnitude of this vector? Can you tell me the magnitude of this A vector? Just type the answer. Adrit, just type the answer for this one. Magnitude of this A vector. Magnitude is represented with either this or either only this. Okay? So just type the answer for the magnitude of A. Not root 3, it will only be 3. Okay? Look now, what this represents? This represents, this magnitude represents only the actual value, right? So look, this is one thing, this is going to be one thing. If I ask you what is the A vector? A vector is nothing but A vector started from here, it ended here. So what is the magnitude of the actual value? So you can see the actual value in I direction is just 3, right? So what is the actual value? That is 3. So magnitude comes out 3. Now clear? If yes, then try to compute if A equals to, let's say B is equals to 3i plus 4 4g. Compute this one if you are clear with the upper. Okay. Try to figure out what is B magnitude. 5. Okay, makes sense. The reason is, again, you can see that this part is in here, right? If I just made the that part, it will 4 will come up like this. So what is the actual magnitude? Basically, the vector will be pointing somewhere here. Common point, right? Like this. So the actual magnitude of this, you can simply say that join. This is 90 degree. You can say this whatever the same this length, the same is this. Okay. So you can simply say this is 3. Yeah, this is 3. This is 4. So the this will come out as 5. All right. I'm giving you another vector C. C vector basically. This C vector comes out as I plus 2j plus 2j. Try to compute the magnitude of this vector. Root, yeah, 3. Okay. So basically, how we can calculate as simple as that magnitude of any vector can be calculated as if let's say C is represented, if any vector that is represented in the form of V as V1 I cap plus V2 j cap plus V3 of k cap. Okay. If any vector is represented in V1, V2, V3, so you can say that V vector comes out as V1 square, not this, just V1 square plus V2 of the square and the V3 of square. So this will result not square, this will be square under root. But this is the formula to calculate the magnitude of a vector. Understood? I'll move to the new page. So we are done with the magnitude of vector. I will now explain position vector and displacement vector. Okay? Let me know if you can see this position and displacement. Position vector first. So position vector is very simple. The vector we were representing till now, that is a position vector itself. Okay, it represents the positions, magnitude, and direction. Okay, and direction. When I say direction, I need to look from how I'm looking at the direction. For example, if I say this is north, south, west, and east. Okay. Let's say this is a point A. If one person is sitting here, if I ask him in which direction A is of use, for this B, A is sitting in this west direction, right, the east direction. For this C person, the A is in the west direction. So basically, the direction, when we talk about the direction, we need a reference point from where we are looking at. Okay, so basically, the position vector is like if you are calculating the magnitude and direction with respect to origin. Okay, and you take a vector from the origin, so that comes as a position vector. I'm just making x and y plane. Okay, so you can simply say that this third vector is nothing but vector, position vector. This is the point of this x and y all things, so you can write this as whatever x and y. If this contains z also, you can add z. If not, then that's fine. Other clear to you? Okay. Now we come up with a displacement. What is displacement? Displacement is basically displacement vector basically gives displacement, okay, from a point to another point. from one point to another. When I say another, this another can be the same point itself. Okay, for example, let's say this is a coordinate plane, and you had a vector A. This is a vector. Y and X. You know what is displacement. I am going to do some displacement. Okay. Initially, I was here. You can see my cursor. Okay. I'm here. I started traveling. I traveled here, here, all the direction. I traveled. Finally, I reach here. You know what is displacement? Very shortest distance. What is the shortest distance? Exactly the point, this line joining both of them. So this is going to be a displacement. I will say this is point A, this is point B. Displacement vector from A to B. Okay. So if I say A is xi, basically x1i plus y1i, y1j, and b I say as x2i plus y2 of j. So what is my displacement? You know what is displacement, right? Displacement is nothing but change in position. Understood? Change in position. And what is the position? Final position is b. What is the b? x2i plus y2j. When I say the position change, final minus initial, x1 of I plus y1 of j. If you just solve it out, what you have to do? You can't do like you are subtracting I from j, right? Because I know this data, I will subtract this value from this one. Not, I can't do this like I will be subtracting this value from this one. Okay, this thing we have to keep in mind. So just pair all I with I, so it will be like x2 minus x1 of I vector plus y2 minus y1 of j vector. Okay. If more often you can add the k direction also. Okay? The 3D is not easy to visualize, so I did tell you. Let's just put a yes or no if you are clear with the things we have discussed so far. Okay, is it clear about the displacement vector? Just put a yes if you are clear with the concept of displacement vector. Okay, so now I will discuss about small page. So let's discuss about the resulting vector. Very important, I guess. Look, right now we are just discussing theories of vector. This resultant vector is something but a way to add two different vectors. Okay, resultant is basically the vector which can present two or more vector. Okay, can be called as resultant vector. Okay, you can a very good idea of representing this as just assume this was a point and this was another point. Assume Adrit, you started from here, you reached here, okay? And then from here you went in the upper direction. So finally you have reached here, right? So what was your displacement if I ask in the form of coordinate plane? So you will say in x direction I moved this vector, so I will say this is my position vector in x direction. Can I say this? And just choose the color. So this is the direction in the y direction. Basically, this is y, and this is your x coordinate. Okay. So you can simply say that in x I moved by this value, in y I moved by this value. You can see these are two different vectors, right? But and this is your position. Whatever you have changed. So don't you think I can also represent this directly by this by saying this? I have only moved this. Now when you say this thing, you can simply say that this is a result of x and y. Even although you already know this resultant is nothing but x vector plus y. Can I say this? In general, this right. So basically, you can see resultant is basically you can have two or more vectors which is represented by a single. If I add a z direction, this will shift to in the little bit in the z direction also. So this will be the vector. Okay, this could be the vector which includes a z also. So you can see I'm representing a single vector in the form of multiple vectors. Okay, I will remove all these things from here. Basically, I'll be just removing the part where I introduce a z direction. So that's it. Although in this part where I can write this x vector as x, basically the exact value, and the direction I know that is I. Y here I can represent as y and j. Okay. But this is not all the time. Like here it was proper 90 degree, but every time it is not necessary to be 90 degree. So you can simply say that if any vector is there, which is in the form of A, which is also in the form of B, okay, so I can represent this vector by some resultant vector which goes in the center. Not it is not necessary. It depends upon the value, like this. So this will be your resultant vector. This is A vector. This is B vector. You know very well that A plus B resultant can be written as A plus B. Clear? Okay. Basically, resultant, if you say, means net result of addition of these vectors. Is that fine? Okay. Now, other just another thing. Assume this is a vector here, and this is another vector here. You know that I can if I take this vector, okay, let me remove it. This is a vector. You know that I can put it like this. Okay, if I just take it from here to here, wait a second. This is my vector, right? And what is the resultant? Resultant will be coming out somewhere here. Okay, I'm not sure what it is coming out. If I take this vector from here and place it here, does it make any difference? Because you can see earlier this was a vector, this was a resultant vector, this was b, this here it was b vector, right? If I place b from here to here, does it make any difference? Other tell me first, does no, right? Because still this vector have the same magnitude as earlier, still this vector has the same direction as the previous vector. So I can say that if a and b have not changed, it means the resultant of this a and b will be the same. Can I say this? I can represent this vector from. I can keep it from here to here. Can I do this? Because this is the result vector. I have just switched the position. So this is what your resultant will look like. Okay. Notice one thing: head of B joined with the tail of A. So what are the remaining part? Let's say this is one head joined with the tail of another. So this is the head of remaining. So just join the remaining. What is this tail? This head. Join it. You will get the resultant vector. Clear? Adrit, look at this and let me know the thing. So let's solve one problem and after that we'll move to the next. Okay, I'm changing a new page. There we will solve one or two problems. Two problems basically. I'm writing a problem to solve it. Two vectors are given. Okay. What can be two those vectors? Let's say one vector is p vector. Okay? It is this is represented in the form of 2I minus 3j plus 6k. Okay? And another vector is q vector, which is basically this is not 6. Okay, this is b, okay, a variable b, and q is nothing but I plus j plus k. If both vectors are parallel to each other, then the value of b you have to decide. B. You have to calculate the value of b in that case. Try to solve this one and let me know the answer after that. Okay, solve this one and let me know the answer. These two vectors are parallel in nature, and in parallel, if vectors are parallel, then their direction are similar. Okay? This is a hint for you. You can take. So B won't be a vector. Okay, it will be just a value for you. Look now, B is not a vector, which can give you the result. It's not a vector. Okay? Do one thing. I'll just explain this. When I said they both are parallel, what does this mean? Their directions are same. Okay. So what I have to do is, I will try to compute the direction of these individually. So what is the p vector? This is given, right? P magnitude into p. So what is p unit vector? Whatever the vector is, 2I minus 3I plus bk. What is the magnitude? You know the square of each and divided by that. So 2 square basically 4, 9, and the last is plus b square and under. This is the magnitude. If you divide the whole thing, you will get the unit vector of p. Okay. Same q vector. Q unit vector. What is the q unit vector? I plus j plus q divided by under root I 1 square plus 1 square plus 1 square until give this gives you 3. Okay. You have to equate both of them. If you equate both of them, what you are going to get is I to be equated with I means basically in same of extraction. right? So yeah. So this is one thing. If you just solve this one, what you are going to get is, you can see out of this whole thing you have just a single variable. So if you just get this value, what you are going to get from here, you square both sides. 4 divided by 4 plus 9 plus b square is equals to 153. This gives you 12 is equals to 913 plus b square. Okay? So this gives you b is equals to minus 1. What does this mean? That it means that this vector will never come parallel to this. This is the one thing it says. That there's no possibility that b comes out parallel. The reason is b square comes out minus 1. It suggests that b is an imaginary value. Okay. Understood this part till here? All right. So that is the thing. Basically, you can't get a parallel vector. This suggests a very good thing. Okay, if you have got b as imaginary, mean to say these vectors can be parallel in imaginary condition, not in the real condition. Let's move next. Second problem. Okay. We are done with the theory for today. Okay. I won't discuss much more theory. Mm, I'll just discuss one more problem. That is, and then tomorrow I'll start with a new fresh topic. Addition of a vector. In that we will discuss two theories: triangle of a vector and parallelogram law of vector. Okay. So followed by multiplication number. So the problem is, you are given three different vectors. Okay, I'll be giving you three different vectors. Vector A, that is 2i plus 2j minus 2 times of q. B vector given is, mm, what can I take? 5 of I plus y times of j plus 5 of k. So this is a vector B, you can take. 5, 2 minus 2. Okay. Remove this 5. It is not 5, just only k. And the third vector C. Can you see this? Wait a minute. I think you should be able to see this. Why you can't see this? Let me know if you can see this. Okay, were you able to see the first problem? Question first. Okay, just wait a minute. Let me check. Can you see the problem now? You can't see. Okay, do one thing. Rejoin the session once again. Okay, you might be able to see that. Just rejoin the session once. Okay, do it once. Now, can you see the screen? All right, fine. So look, this is the question, okay? And the problem says all three vectors are coplanar. Are coplanar. Coplanar means to say they all lies in a single plane. If I make a plane like this, all three vectors are lies on this point, okay? Maybe like this. Let's say this is a plane, okay? All three vectors are here itself, maybe in this plane. There's no case that one vector is perpendicular to this in this direction or not. If this case, this is not coplanar with this. Here I have given you A vector, B vector, and C vector. So all these three vector lies on a single plane. Clear? So this is the question. Just try to solve this. After that, I will give you the hint or basically final solution. If you are not able to understand how to solve, just let me know first. Should I give you the solution? Should I give you the solution for this one? Okay, look, what happens is, yeah, fine. Look, when you have two vectors, if they are coplanar in nature, what happens is just a simple idea to you. For example, this will have a coordinate plane, maybe this, and the another one will be this. Okay, so assume three vectors are there. Assume a value three vectors are there. This is one, this is might be here, and this might be a random three. You know what happens in general is, I can represent any two vectors in the form of sum of the third vector. How? Because you know that if I wish, what I will do, I will take this vector from here to here. I can take this vector from here to here. Okay, and if I multiply this vector by some value, if I multiply it by some value, or you can simply say that if I multiply this vector by some value, you can see this this can be represented as a sum of this vector. Can I do this? Result basically, you can say the third vector is sum of this and this. Can I say this? Not exactly this basically. I had to multiply and divide. Basically, you can see this was this much, this was very high, this was a very small. So what I will do, I will just take a random value and I will just multiply it with it. So let's say m times of a vector. Meaning to say this m can be 100 into, basically I'm multiplying for making it big. You can make this m as 1 by 100, basically dividing also. So this is what some factor. So what happens is any two vector choose it. Let's say I'm choosing the B and C. So what I will do, I can represent A in the form of m times of B vector, basically multiplying B plus n times of C. Okay, understood till here? Just let me know first. This is the main important part. If vectors are coplanar, you can represent any two vectors in the form of in the some summation form of in the third vector. Okay, if they are coplanar. Let me know first if you are clear with this concept. Okay, I won't solve further because we have not studied a lot of things to study. Just this was the main concept I wanted to explain. Although you can calculate actually in the final answer, you can easily calculate. How you can calculate? You can simply see you will be having a lot of equations. What is a? That is 2i plus 2j minus 2 times of k. Okay, this is represented as m times of 5i plus n times of 1. So this is 1i, okay, plus 5 times of this y value of I cap plus not 5 actually, it should be m y m. Basically I was multiplying m with a b, right? Plus this is, I think this is nothing, only k, so you can say k times n times of 2, okay, to make this h. Plus the last one is basically it should be c, yeah. M times of k basically plus n times of 2. So you can simply say that this m plus n, basically 5 times of m plus n, this is equals to this 5y, basically m times of y plus 2 times of n is equals to how much? This 2 value. And the last one is m plus 2n is equals to minus 2. So you can simply say that from here, these if you solve these two equations, you will get the answer for You will get the value of m and n. If you put this m and n, you will get this y value, okay, from here. Understood? And I will give you the final answer also here. So the m, if you just solve it little bit more, you will get m is 2 by 3. What I can see as n, you may get somewhere around maybe 4. If I just put 2 by 3, I'll be getting something around minus 4 by 3. Okay. And if I just put the same value, whatever m n is, so this m 2 by 3 minus 4 by 3, which comes out as minus 4 minus 8, something like that. So yeah, it will come out as 7. These are the values you are going to get. Let me know if you're clear with this thing. If you're clear, we can end the session by now. Adit, hello, I'm audible. Got it, right? So that's all for the today's class. Adit, we can end the session by here. Okay, you can leave. I'll give you the PPT and PDF and all things. You'll get it by. So, Adit, keep going.